Stoichiometry problems involving a gas phase reactant or product are really no different from other kinds of stoichiometry problems. So like any other stoichiometry problems, it's all a question of looking at the balanced chemical equation and looking at the ratio of moles from one reactant to another reactant or to another product. So if we started off with a gas phase reactant, we would just go from the amount of gas, and that would usually be the pressure and the volume. We'd use that to find the number of moles, and we'd go and use that to find the number of moles of something else. So maybe the gas is a reactant, and we'd find the moles of product, and then maybe we'd find the mass of a product, something like that. Or we might have the mass of a reactant, and we could use that to find the moles of gas as a product, and then the pressure and volume for that particular gas. So let's do a specific example. Okay, so suppose that hydrochloric acid is reacting with zinc and it's going to liberate hydrogen gas. So let's put our phase labels on. Okay, so we've got this aqueous phase reactant reacting with some solid zinc. It's going to oxidize the zinc, form zinc chloride. It's going to reduce the hydrogen ion from H plus to H0, and that's going to be liberated as hydrogen gas. So we could imagine a stoichiometry problem being based on this reaction. So in this problem, we're given that there's a certain amount of zinc, and that's going to be the limiting reactant because we're given that the acid is given in excess. And the question asks how much gas is produced. We're asked for the volume of gas that's produced at a specific pressure. Of course, the higher the pressure, the lower the volume. So we can't figure out the volume unless we're given the amount of pressure. Okay, so we're going to do the stoichiometry problem. And to do it, let's lay out our strategy. And our strategy is going to be that we're starting off with the mass of the zinc. We can go to moles of zinc. From that we can get moles of H2 because we've got the balanced reaction up here, so we know that for every mole of zinc there's going to be 1 mole of gas. And then from the once we've got the mole of H2, we're going to use the ideal gas law to get the volume of hydrogen. So that's our overall strategy. Let's do the problem on the next page. Okay, so we're given that we have 130 grams of zinc. We want to change that to moles, so we look up the molar mass of zinc. We see that's 65. So we've got 65 grams of zinc for every 1 mole of zinc. So we can cancel our grams of zinc. And then we're going to take that, and I don't really have space here, so I'll just draw a little arrow. We're going to multiply that by another conversion factor. We've got the moles of zinc. We want to go to moles of hydrogen gas. In this case, we saw there was 1 mole of zinc to 1 mole of hydrogen. We should do this every time because sometimes it won't be 1 to 1, so we should check every single time. So we got rid of our moles of zinc. Now we've got moles of hydrogen gas. And at this point we can figure out how many moles of hydrogen we have, so we can just go through the numbers here. We have 130 divided by 65, and so that's going to be 2 moles of hydrogen gas. But the problem asks us for the volume, and let's go back and look at that problem. So the problem statement asks us for the volume if the pressure was equal to 1 atmosphere, and it didn't give us the temperature, but if this were like a test question or something, it would actually have to give us the temperature too. Let's go ahead and say that the temperature is 298 kelvins. So if we have these two things given, we've got the pressure given and the temperature given, we know the number of moles, we can use the ideal gas law to find the volume. So let's do that on the next page. So the ideal gas law says that PV is equal to nRT, and we saw that we were given the temperature, we were given the pressure, we want to find the volume, so that's our unknown. We already figured out how many moles of hydrogen gas we are, and we just have the universal constant R. So our unknown is volume. We're going to solve for that. So V is equal to nRT over P. Now at this point, the only trick is to make sure that we use the right version of R for the units that we're using. So let's set up the rest of the equation before we put in R. So we said we had 2 moles of H2. And we're leaving R blank for now, and our temperature was 298 kelvins. And you can only see that, but that's a K for Kelvin. And the pressure. All right, where our pressure was given in atmospheres. So we can see we want something that's going to cancel this to give us units of volume. And since we're using atmospheres as pressure units, it's convenient to use the version of R that is 0.08206. So we've got 0.08206. I'll write the units out here. That is going to be liter atmospheres per mole per Kelvin. And so we can see that the kelvins on our temperature is going to cancel this Kelvin. It's hard to see here. Is going to cancel this. So that'll get rid of the kelvins. This mole is going to cancel that. And we're dividing by atmospheres. I'll get rid of that. And so we're left with units of liters. So to finish the problem, we just plug in those numbers. We get the volume is going to be equal to 48.9 liters. And if we go back and look at our original data, it was really only given to, so our data was only given to 2 sig figs. So really we should call this 49 liters of H2. And that's our final answer. So you can see doing a stoichiometry problem with gas is just like doing it with solution phase or with solid. We always have to go through the balance reaction to figure out the molar ratio of our products and reactants.